when we are talking about two planes, there are only three possible interactions. Okay, so the thing is, one is they can be parallel to each other. Okay, so if there is a plane like this, okay, and the other plane can be parallel to the first plane. Okay, it's like a stack of paper. Yeah, they are parallel to each other. This is one type of interaction. There is another type of interaction. Okay, they can be parallel and at the same time overlap with each other, which means the equation of two planes are actually of the same plane. Okay, they are overlapping with each other. That's the idea. This is the second type of interaction that you can see. And the third type of interaction is when they intersect each other. So let's say there is a plane like this, and let's say there is a plane like this. Well, these two planes, okay, these two planes are actually intersecting at a single line. Okay, intersecting at a single line. Okay, so this is that line in which they are intersecting. Okay, so we have three types of interactions between two planes. Okay, so how can we find if two planes are parallel to each other? Okay, if the normals of two planes are parallel to each other, we can definitely say the planes are also parallel to each other. Okay, let me prove it to you. So let's say this is phi 1 and let's say this is phi 2. If phi 1 is perpendicular to n1, okay, let's say this is the normal vector n1, okay, and let's say phi 2 is perpendicular to n2. Okay, so this is perpendicular to n2. So the thing is, if n1 and n2 are parallel to each other, okay, if n1 and n2 are parallel to each other, the thing is, the line connecting these two vectors, okay, the line connecting these two vectors, okay, you can clearly see that must be perpendicular to the given vectors here because that lies on plane phi 1. Okay. Similarly, if you extend n2, okay, you can clearly see the phi 2 is also perpendicular to n1. Okay. So this means phi 1 and phi 2 are parallel to each other. Why? This angle is also 90 degrees. So you can definitely say phi 1 is parallel to phi 2. Okay, so if two where the normal vectors are parallel to each other, then the planes are also parallel to each other. Okay, now how can we talk about phi 1 and phi 2 overlapping with each other? Well, the thing is, okay, if you can write the equation of phi 1 in terms of k phi 2, okay, the Cartesian equation in terms of like this, well, then we can definitely say phi 1 and phi 2 overlap with each other. Phi 1 and phi 2 overlap with each other. Okay, overlap with each other. This is the condition. Okay, but before you go to this condition, you have to make sure n1 is equals to k n2 because if they are parallel to each other, that implies n1 is equals to k n2. Okay, so this is the first thing you have to prove. Then only you can prove this guy. Okay, if n1 and n2 are not parallel to each other, okay, we can definitely say phi 1 and phi 2 are not parallel to each other. Okay, so in this video, what we are going to do is we are going to focus on how we can come up with the parallel planes and also the overlapping planes. Okay, so let's do this. So let's say we have a question like, so the question states that phi 1 is given by the Cartesian equation 3x plus 2y plus 7z is equals to 21 and phi 2 is given as the Cartesian equation 9x plus 6y plus 21z is equals to minus 13. We have to make sure whether these planes are parallel to each other or they are intersecting with each other. Okay, if they are parallel, we have to check whether they are overlapping with each other. Okay, so first of all, let's check the n1. Yeah, so let's say phi 1 is perpendicular to n1. Well, then n1 can be given as 3, 2, and 7. 3, 2, and 7. And let's say we have phi 2. Well, phi 2 can be given, phi 2 is perpendicular to n2. So n2 can be given as 9, 6, and 21. Okay, so if you see here, okay, normally what we do is we multiply by one number and see, or you can do like a ratio method. Okay, so here you can see 3 over 9 and then here you can see 2 over 6, and here you can see 7 over 21. This is equals to 1 over 3. This is equals to 1 over 3. This is also equals to 1 over 3. Okay. So the ratio of the coordinates are equal, which implies n1 is actually parallel to n2. This implies phi 1 is actually parallel to phi 2. Okay. So you can definitely say phi 1 and phi 2 are parallel planes. Phi 1 and phi 2 are parallel planes, like a stack of paper. Okay, fine. Now we have to check whether they overlap with each other. Yeah, we have to check whether they overlap with each other. So for that, let's check. So this one is multiplied by 3, 9 we are getting. 2 into 3 we are getting 6. 7 into 21 we are getting 21. But 21 into 3 is 63, but we are getting minus 13. Okay, so phi 1 and phi 2 cannot be overlapping planes. Okay, so this is the basic idea that you have to keep in mind. Let's do another question. So in this question, try it by yourself. So what are they saying? They are saying pi naught is given by 4x plus 2y plus 8z is equals to 20, and pi 2 is given by 6x plus 3y plus 12z is equals to 30. Okay, so first of all, let's say pi naught is perpendicular to the vector n naught. So n naught can be given as 4, 2, and 8. Okay. Similarly, phi 2 can be given as the perpendicular vector to n2. So n2 can be given as 6, 3, and 12. Okay. So what are we going to do now? First of all, let's check whether n0 is parallel to n2. Okay. So the thing is, actually it is parallel to n2. How can I say that? Well, let's write down the ratios. 4 over 6, 2 over 3, and 8 over 12. This is equals to 2 over 3, this is equals to 2 over 3, and this is equals to 2 over 3. So they are equals to each other, which implies, okay, which implies n naught over n2, sorry, n naught is n2 is actually equals to 1.5 of n naught. So this implies n2 is parallel to n naught. Okay, this implies phi 2 is parallel to phi naught. Okay, so we know phi naught and phi 2 are parallel vectors. Okay, so that's it. Now, how can we find whether they are overlapping or not? Okay, so by multiplying this by 1.5, okay, we got 6. Similarly, here also 1.5, here also 1.5. So if we multiply 20 by 1.5, what will we get? 30. So yeah, phi naught and phi 2 are overlapping planes. Pi naught and pi 2 are overlapping planes. Or you can say they are the equation, the Cartesian equation given in both cases are the same equation. Okay, so keep that in mind. So this is what I wanted to focus on this video. In the next video, we will focus on how to find the line, the equation, the vector equation of line at which the two planes are intersecting with each other. Thanks for watching the 35th video in our vector series. If you found this explanation of interactions between two planes focusing on parallelism helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.